Welcome back to Databytez, your source for data-driven content. Today I'm in front of the camera because we're going to be exploring a different way to conceptualize data structures. Now, in a previous video, we looked at the different types of data structures that exist, the most common ones that you'll be dealing with, and it's kind of abstract. It falls... I feel that it's not very intuitive for a lot of us because we don't really deal with abstract things. We deal with things in the in the physical realm. We like touching things with our hands. Being able to touch things is actually very important, and being able to conceptualize things physically in the physical sense allows for a more intuitive understanding. So in order to do that, I'm in front of the camera for you today, and I got these things, these blocks. Now, you might have encountered these blocks when you were learning to multiply back in the day. So your foundations of arithmetic. Now, they're actually very good for also exploring data structures in a more concrete sense, being able to hold them. And I really like that because we have a couple of things that we can then build on. So let me take a couple of things here, pull them at the ready, and we'll explore the different options we have available to us. So, starting off with these yellow squares, you can conceptualize these as cells on an Excel sheet, or you can also look at them as bits of data. And when we discuss arrays, and this is also, before I go on, this is a tensor of rank 0 because it is just a point. It is just a single point here. There's no real dimensionality to it. It has 0 dimensions. But we can take a couple of yellow squares and put them together, right? So these bits now have some more structure to them. That is now graduated from a tensor of rank 0 to a tensor of rank 1 because it has, or you can even call it a vector because it has, it takes a line through space, and it has, you can now, if you had something for capturing direction and magnitude, you can do that as well. I guess the magnitude of how many bits here are. Also an array. Again, I say all these different things not to overwhelm you with words and vocabulary. In fact, I don't think you should memorize all of them in so much as, again, the concept of it. All it is just things together. And you add a vector, you have just something with direction. It's the same concept again. It's not something wholly new. It's just everything is rinse and repeat under a different name. And so if you have enough yellow things together, again, following this array thing where everything is next to each other, or even a linked list where you can say this, it's hard to kind of put here, but you have one square, and at the end of this, you can imagine there's some instruction to find the other square over here. That would be a linked list, but for simplicity's sake, if you have enough of them together, you get this green one. And this green one is your real formalized array. And it can have either be oriented this way, you could have a row, or you can have a column. Now, if you have enough of these arrays put together, right? You put 1, you put 3, and you just imagine you keep going, it's starting to look like something else, right? And if you work with pandas in Python, the library pandas, a data series, which corresponds to this, if you remember our discussion on data structures, it's parallel to the array. If you align enough pandas series together, you get the data frame or the table. And so now you're dealing with tables. And this is also known as a tensor of rank 2. And there's something important here, and you can't really notice it. And it's kind of when I was talking about these green ones, about how you go from row to column, you can start playing with the orientation. So this would be considered a 1 by 10 array, and this would be considered a 10 by 10. Now you can reshape it, right? So you can take a 1 by 10 and make it a 10 by 1 if that's what you need to do. All the values here now get more pivoted and gone this way. Same way here, you can take this and you can move it around. And this reshaping aspect, this ability to move data through space, is something that really comes into play when you start cleaning data, or when you start wanting to use some kind of dimensional component, kind of like how we were using the switch function to kind of play and sort of leverage n-dimensional arrays in Excel, because it doesn't deal with that natively. That's something more Python and NumPy related. But again, kind of like how switch was, we had some kind of key, which imagine the key, there's like an A here, a B here, and a C here, and we stack these tables together. If we want to say, I want to pull the table corresponding to index A, I pull this one out and I play with the data here. Maybe I'm filtering or doing some other transformations. If I want to play with the table corresponding to index C, A, B, C, I pull out this, or even B, I pull out this. And so I'm able to do this, but I'm also able, so this would be a 3 by 10 by 10. I could also go this way, this way really. So I'm able to shape it now this way. So I have, is this a good one? And this might not be the best way to do it. Yes, I can do it this way. Sorry, even the abstractness for me is a little bit much sometimes. But I can now, instead of going through these ones, I can go down this way. So I have a 10 by 4 by 10. Again, the way you're able to play with these dimensions, or if I want to, 10 by 3 by 10, by able to switch it from here to here. And then I am able to switch it back. And then I have a 3 by 10 by 10 yet again. So I'm able to play with this a little bit. Imagine instead, if I were doing this a 10 by 3 by 10, I would say I want to go 10, and then I want to go 3, and then I want to, or 2, and then I want to go 5. I would put something right here, and I would pull this out. And it all depends on how I orient it in space. Once we start getting into 4 dimensions, it really becomes hard to try to do something like this. And again, this is a model, so it's meant to just kind of bring a physical component to this kind of abstract talk. And it's not perfect in capturing everything, but I think it does a great job. So continuing on, and let me know in the comments if you think differently. Maybe it's not helpful, but being able to turn this physically in space, I think, becomes more intuitive than trying to think, okay, if this is the 3, then I want this to be 10, and never having your will to ground it. But if we start stacking these, and now it's a tensor of rank 3 with dimension, you have enough of that, you have the cube. So this is a true big 3-dimensional thing. It's all one thing, and it's a 10 by 10 by 10. And so we're able to spin it. No matter what way we spin it, we're going to get 10 by 10. And this is the tensor. This is the best way to conceptualize 3-dimensional data sets. And if you go on beyond this into 4 dimensions for whatever reason, you can't play with this anymore. But hopefully, this has been a great way to think about data in a different way. Let me know again in the comments if you found it helpful, if you want to revisit this and have another question, if you want to see the blocks again and in another way. Maybe as we're examining other videos on data, we can pull out the corresponding shape. So again, you get an intuitive feel about how to deal with data. Because when you start cleaning it, when you start cleaning your data sets and you want to pivot and reshape things because you want things to be you want certain dimensions in there, it helps to visualize these squares. Anyways, that's been Patrick from Databytez. I hope you enjoyed the video. Have a great rest of your day. Stay data driven. Bye.